All right, so let's get started. Thanks, guys, for having me today. I'm actually pretty happy to be at LambdaConf. The setup is really nice, so thanks for having me. So today, well, I come mostly to tell you a story, and that story is that the way we build cloud applications today sucks. It's really bad. And it's really bad for a variety of reasons, especially in the FP community. I'm sure you know something about it. I'm going to illustrate that with a real-life story. So before being at DBOS, I was at a company whose mission was to orchestrate data pipeline. Like they wanted to have people run their data pipeline on time. This company was the Apache Airflow company. I don't know if you've heard about Apache Airflow. It's an ETL orchestrator. The company name was Astronomer, and to accomplish that mission, we kind of manage hundreds of Kubernetes clusters for customers. Now, here's an example of what our application will look like. So we had this API that will take in, let's say you had a deploy Airflow endpoint, and it will essentially be a sequence of steps, right? So first, maybe I will be configuring the deployment. I will be managing some secrets, storing them in a third-party secure secret store. Maybe I will manage authorization, which I will also do with a third-party RBAC system. Maybe then I will start generating Kubernetes manifests, yet also done with a third-party API. And finally, configure some observability, stuff like that. So this is essentially a workflow of steps. We're using a very procedural way to do it, and it's actually it was very hard to get it right because, as you can see, the state for each of these nodes in the graph, the state was distributed across a variety of third-party APIs. So how I will be building this application before DBOS was, I can tell you, it was very sad. It was the sad way, the sad and painful way. And maybe that's a story that some of us can relate to. The correctness, building the application such that it's actually correct, it was a tech debt. Like we eventually wanted to just throw together some code, have a product, and say, okay, we can go to market. We're a startup. We need to get things going. Now, of course, that kind of worked when state wasn't that business critical. If you have a stale record in the database because at some point the workflow kind of crashed, it was kind of okay. People will restart, it will eventually work. The traffic was low, there was not that much activity, so it kind of went under the carpet for quite some time. But guess what? As any company can hope for, the product actually grew. People started saying, oh yeah, we want you to deploy Airflow and manage it for us. It was really interesting. And the problem is that it grew, all this tech debt of state management that we did not handle before. Well, eventually, those problems become serious enough to have people page at night. In fact, the problem was so bad that at some point, a huge fraction of the infra team was so busy band-aiding the production system that they will not just be able to write new features. And new features is what was fueling our growth, right? Because people wanted more stuff. So, we kind of patched the situation. We're like, maybe let's add some compensating actions. You have this workflow of steps talking to different APIs. So we're like, okay, now we need to, if something fails, we actually need to roll back a bit everything that happened to maintain the state correctly. So that was very tedious and error prone. We'll have to go inspect the code and figure out, if else do that. And it didn't cover all the situations. Like, a very simple situation, if we were updating a Kubernetes cluster and rolling out a new image, guess what? Kubernetes is just going to shut down a pod that might be receiving requests and processing them and just spin up a new one. So we'll be praying that if something happened to the pod, no request was in flight and the state will not be untouched. Later, we added an external workflow engine. So to not name the elephant in the room, that was a very complex integration that only worked because we have 8 or 9 people in the infra team who knew how to add another service, who knew how to do this kind of hook in this complex integration. Eventually we had 1.5 person working on that workflow engine full-time. So what's 300K or 400K a year when your infra burn rate is already in millions, right? So, okay, well, sure, that's fine. Okay, so, well, tell me, okay, maybe this is just because we're all bad programmers. You know, maybe you write the code right the first time, and it compiles, and it never crashes, and the state always works. Sure, that's fine, right? Maybe. I mean, doesn't work for me, but maybe. Now, the problem is that in addition to getting the code right, you actually need to operate the cloud. You know, it doesn't stop there. Like, you got the code, you published it, it kind of works. You still need to ship the code, secure it, observe it, debug it, scale it so that you can actually more stuff. And interestingly, none of that is your core business. Like, I hope you love writing YML manifests, because that's what you're going to do if you want to operate the cloud today. And none of this is your core business. So, you know, based on that experience, me and the rest of the team, the founders of the DBOS team, all have been, you know, thought about these problems for quite a long time. Like, DBOS comes from academia. It's a joint research project between Stanford, MIT, database and operating systems people who essentially had, you know, these issues, are like people who are thinking that the way we should program the cloud should be in a much more, you know, easier and more intentful than having to band-aid things and write YML manifests. So what we have today is, what DBOS does is mainly two things. The first one is what we call DBOS Transact, which is an open source TypeScript Node.js framework that lets you compose transactional workflows. So we have a workflow programming model, and you will be putting operations together. And what the frameworks will give you is that it's going to manage the state of that workflow automatically for you, in a way that when, let's say, an instance running DBOS Transact crashes, if you spin up another one, you can instruct it to resume all sorts of pending workflows that we're currently executing, and they will resume exactly where they left off. And I'll describe how you know, we do that. Now, you can run, it's open source, you can run it everywhere on, like, I guess Kubernetes is going to be a famous one, but you know, you can use any like Google Cloud Functions or other execution runtimes, it will work. It has all the primitives to give you the state management. What we built is DBOS Cloud, which is a serverless platform specialized for these kind of workflows. And you know, it does all those things that, it takes on all the accidental complexity of the cloud, in a sense. We automatically manage the observability, we scale your applications, we execute it. We secure it, we have a very tiny attack surface. Under the hood, we use Firecracker, which is the same technology that Lambda is using for their, AWS Lambda is using for their execution environments. And yeah, so the idea is really to provide this kind of integrated experience so that you can just write applications without having to think about all the corner cases of the cloud. Now, so let me just take a similar example to what we had with the Airflow deployment stuff. So it's about the same thing. It's a workflow of steps, and maybe let's say that I want to check out some product. It's the cliche of durable execution, I guess, like the checkout workflow. So first, maybe that's a very simple application. Maybe I'm just going to reserve some inventory to create an order and then process payment through a third-party API. And if the payment works, I will go back to fulfill the order or maybe cancel it. Now, this application has all the same problems that any of those distributed applications has, meaning that it can crash and fail absolutely everywhere. It has sometimes it's a bit hard to get right because the third-party APIs can have some tricky semantics. I don't know if any of you here have used Stripe, SQS, maybe. Right, so we have more popularity for SQS. So you have this kind of events where you need to make sure you're processing an event within a certain time frame, because otherwise another node could process that event and then you will have two concurrent processing of the same events. So those semantics are kind of tricky to get right. Now, the way to build it in Transact is using this workflow programming model that manages the state for you. So we heavily use annotations. So the at workflow will be what you use to declare what a workflow is. And maybe you will have 4 steps. The first thing was that you'll say, OK, I want to perform a transaction. I want to have a side effect and interact with the database. I'm going to declare that piece of code as having this side effect. And once that transaction has been executed, inside the transaction, we'll be recording some metadata about the transaction itself. Doing so, we benefit from all the ACID properties of the database under the hood, because either it executes or it doesn't. Once that step has been executed, if you wanted to re-execute that workflow, the open source framework will figure out where we are and say, OK, we don't need to redo that transaction because it has already been done. Same thing for creating an order. Now to contact the third-party API, we'll be using what we call a communicator, which is essentially a way to wrap this code that is interacting with third-party APIs, and likewise to record the outcome of that effect. We're going to store that into the database associated with the workflow. Now, this is fairly useful. So some third-party APIs do have idempotency semantics. They will give you a way to make a call and give an idempotency key, and if you were to make that call again, they will handle that for you. But that's not always the case, and even though sometimes they also have tricky semantics. So the nice part about this programming model is that because everything is tied to a workflow, idempotency is automatically managed for you. Now, one thing to note with communicators is that for this, we provide at least one semantics, because it is possible that the network call, before the return of the call and us checkpointing the state, there is a critical failure. So that's important to note. And finally, we'll be fulfilling the order, another transaction. Now, this is fairly abstract, so I will also kind of try to pump you up to like how much easier this is to write when you have the right programming model where the orchestration is embedded inside the programming model. Let's say that I want to use AWS Lambda to write this application, just to receive the callback from the payment to write this webhook. I probably have to do something like that. I mean, it's more than probably. It's like we looked into using that to do it, and that's what we found. You'll probably need to have some sort of API gateway that processes that event to have a Lambda processing the request. And then you have to put it into a queue to have a notification that say, OK, the payment was processed. Now you can resume that specific workflow wherever it was. And figuring out wherever it was is another question. And then you will finally store that into RDS. Now, if you use the combination of Transact and DBOS Cloud, this essentially reduces into that. It's kind of simpler. Now, if you wanted to use, there is an intermediate step. You can also execute it on your own if you wanted. But all this, for example, with just Transact alone, you can remove all the SQS parts, all the step function, and event bridge parts. You will maybe just need to write the lambdas, and the lambdas will be more complicated to write. So I'm going to do a small demonstration, which of course is susceptible to all accidents that live demonstrations can have. Okay, it's probably, who knows. So let's say that I wanted to implement this beautiful, and I know you all want to do it, but wait until I'm done before destroying this publicly available URL, because you can. But let's say I wanted to implement this beautiful widget store, right? It's doing exactly what we said it will, meaning that when I click on the buy button, I am triggering a workflow. I have been redirected to the third-party payment service. You can see the the workflow ID, the idempotency key is here in the URL, actually. So that workflow has been created, and, well, of course, if I confirm the payments, everything is going fine. I have only 99 items. Impressive, right? I know. But maybe let's say that while I have this application, and hopefully my store becomes popular, so I have like a lot of, hundreds of requests, hopefully hundreds of requests per second, like I would love that, right, for my store. And there is this Eisen bug that kind of happens only when there is high concurrency and high load on the system. And at this point, something happens. So something happens, everything is dead, boom, crashed, this is done, it's finished, no more, nothing is done. Now, any modern execution platform is gonna detect that the runtime, the execution engine crashed. Like Kubernetes is gonna tell you, oh, the replica set is supposed to be 4 nodes. There is only 3 running. I need to spin up a new one, right? So that's kind of standard and what you would expect for a compute platform. The additional thing that DBOS Cloud does is that not only it will restart these things, but it will say, oh, wait a second. That VM that crashed was also executing workflow 3229, whatever it is, and will instruct DBOS Transact to resume that workflow exactly where it left off. And that's possible because the DBOS Transact has all the primitives to recover workflows. It has an API that lets you say, OK, restart that specific workflow, and it will just figure out what the state of execution was and do it for you. So now I can resume, confirm payment, and that's the same workflow happened. So you can play ahead with it. Now you can go ahead and press the crash button as much as you want. I'm done. The other thing that I will plug in is that the way you will, is this visible? This is probably not very visible. Okay. So the way the experience that we wanted to have. So I did a lot of programming for the cloud, and I was always very upset that I wasn't really able to test locally. And I had to use, if I wanted to update the code on some cluster, I always had to find some trick to there are some ways to do it, but typically you will have to update the code on a specific branch, wait for the CI to actually go through to create a new image, and to have the code run in dev. There are ways to speed this up. There is some ways to essentially open ports and connect directly to some of the servers and the pods, etc. But it's not super straightforward. So the experience that we wanted to have is that you can, this is Node.js TypeScript. You can just run it locally, test it locally, use standard tooling like Jest and Istanbul for code coverage. And once you have, which is much easier to test than Lambda, for example. To test a local Lambda setup is actually pretty tricky and difficult. Once we have that, the experience we wanted to have is something like, probably going to have to relog, actually. But presumably, I'm already logged in, right? So up, device confirmation, continue with Google. Congratulations, I'm all set. Incredible. So that's the only thing, once you've been writing your code locally, you're just going to have one command line that says, okay, well, let's go ahead, upload it, and you can see the code being updated. Now this is going to take 30 seconds, something like that, so I'm not going to wait until that's done. And I will come back to this. Where is my talk? Oh, it's here, okay. The other thing that I wanted to show, so who wants to see a black screen with weird lines that look a bit technical? Okay, we have more enthusiasm. That's good. So the other thing that we wanted to have is just automatically provide some sort of dashboarding for people. So it's very hard to read, but the idea is that when you deploy this application, you should have access to all one of the things that we do for people, which we think is important, is managing telemetry automatically. So what DBOS transact does is automatically generates OpenTelemetry span and traces for each workflow so that you can plug it in an existing system and propagate the context of that workflow to have tracing. So it's not super visible here, but you will have, if you use Jaeger, for example, we use the OpenTelemetry protocol. So that's kind of very standard going out of the box and just automate. You don't have to really think about that instrumentation anymore. So that's the kind of thing we wanted to provide as an experience. Now, you'll ask me, okay, that's not what I wanted, slideshow. Okay, so we have this system that essentially gives you stateful serverless applications. You do have, the state is managed for you. You have a way to kind of easily resume things where they left off. You have like a much easier time writing correct applications. You don't have to write all the code that when the system restarts has to go into the database and see, okay, what was where and what do I need to do with those things that were pending. You don't need to do that anymore. But now we can, there is some other thing that we can do because we use Postgres under the hood, which is technology we love and embrace. In fact, I can almost both say we created it because Mike Stonebreaker created Ingress and then Postgres. We really like Postgres. And the thing that we found is that because of the way, like Postgres gives you snapshot isolation, and we leverage snapshot isolation in the metadata we give to the workflow for state management. And what we give you, DBOS plus Postgres, is time travel. Shazam. We're not the only ones to do that, but a normal debugger travels linearly in time, and you can go up and down the stacks, right? You progress in the debug, and then you can go up and down the stack. The time travel debugger lets you go back in time and restore the entire state, the state of the program. So GDB, for example, has, I think, a time traveling capability, which saves the state of all your registers and so, and it's pretty heavyweight. What we do is we provide the time travel debugging capability for the database state. So when you have these workflows, let's say that you have this Eisenbug that we talked about earlier. Let's say that the system crashes, and you really want to reproduce that thing. Before that, you'll have to somehow start sending a lot of requests, put a bunch of print statements, and kind of hope, okay, am I going to be able to have enough prints to reproduce that bug and at high concurrency and make sure it happened well? Well, guess what? With that thing, you can replay a single trace. And because you have the entire view of what the database looked like before, you're going to be able to investigate all the other, the side effects of all the other workflows that were happening at the same time that your workflow was running. So it's much easier to debug that. Yeah, so running out of time, I have some parting words. To summarize, we have this open source system that have all the goodies of stateful execution for workflows with a workflow programming model. We built in the platform to demonstrate that if you have this programming model, like you can actually build a serverless platform that's very resilient. And we have a time travel debugger that comes in with the platform that lets you do all those more advanced use cases of debugging. Please check us out on GitHub. We have some repos showing all the code. You can get started. Like we have documentations. We have a free tier on the cloud platform, so you can, if you're interested, you can try it out. It should take like 5-10 minutes to just get something going. Happy to answer any questions now after the talk. Please come to the hackathon on Wednesday, where you can do more of this if you're interested. And if you're not interested, you can still come because we have prizes and you won the prizes. So, thanks for your time, thanks for your attention, and yeah, happy to take questions.
Thank you, Max. That was an excellent talk.
Thank you.
Oh, I actually did have a question. I think we have a little bit of time. You said that you follow at least one semantics. Mm-hmm. So is it up to the application to resolve like a double write in the case that it gets written twice?
So at least once semantics are for side effects that are not on our database.
Okay.
For the database, all the transactions we support exactly once. Please don't be a purist right away, but we support exactly once because we use the database transaction to slip in the metadata. Now, if you have a workflow that is composed of transactions and communicators, your transaction will have that property, but your communicators talking to third-party APIs have only at least once. So it's up to the third-party API to either manage idempotency, for which we automate the generation of the idempotency key.
Okay, cool.
Or not, yeah.
Awesome. Yeah, I was just curious about that. Thanks.
If your third-party API is another DBOS workflow, we also have exactly once mechanism because we use the database, we use Postgres as a queue.
Okay. Oh, okay. Awesome. Thank you.
Of course, thank you.